Hello class. In this video I'll go over the fraction class that's covered in chapter 14 of your textbook. Here is the header file for the fraction class. You have three different constructors here, as you can see. A default constructor, a constructor that receives one parameter, and a constructor that receives two parameters. The fraction has two private data members, top and bottom, both of them integer. So a fraction is represented by, again, the ratio top over the bottom, right? Top and bottom being the private data members. So going back to the constructors, for example, the constructor in line 14 receives two parameters, t for top and b for the bottom, and creates the fraction t over b. You have the function numerator basically returns the value of the numerator, which is the top. Denominator returns the value of the bottom. You have lines 17, 18, and 19. You have the overloading of some operators, in particular the augmented plus operator and increment operator, prefix and postfix operator. And then you have the compare function, which I'm going to go over shortly. The fraction class has two private functions as well. One is called normalize and the other one is called greatest common divisor, which again I'll go over those shortly. So there is the definition of the class. Let's go after the implementation. The implementation, let's start with the greatest common divisor. The greatest common divisor basically returns the largest number that divides both m and n. Let's say you're trying to find the greatest common divisor of n and m, both integer. That would be the largest number that divides both n and m. As an example, greatest common divisor of 8 and 12 is 4, right? Because 4 is the largest number that can evenly divide 8 and can evenly divide 12. So that's what the greatest common divisor will find for you, and I'll tell you where it's used. There is another function called normalize. This normalize function, I think it's later on. I'm not going to go over the code, but here is the normalize function. The normalize function, what it does, it moves the sign to the numerator and also reduces the fraction to the lowest common denominator. What do I mean by that? If you create a fraction such as, let's say, 8 divided by negative 12, if you create such a fraction using, let's say, the constructor fraction, let's say you create a fraction, 8 being the top number and negative 12 being the bottom number, right? What this constructor does, it immediately calls normalize. And what normalize will do for you, that normalize, what it does, it calls the greatest common divisor to reduce the fraction. It reduces the fraction 8 over negative 12 to the greatest common divisor is 4, so it will be 2 over negative 3. That's what it does. But it does one more thing. This normalize function, it also moves the sign to the numerator. So if you have a fraction such as 2 over negative 3, it turns it to negative 2 over 3. So that's the normalization that's going to take place. So once again, if you create a fraction such as 8 being the top number and negative 12 the bottom number, the normalize function will reduce it to negative 2/3, reduces the fraction and moves the sign to the numerator. So with that said, the constructor of the fraction assigns t to the top, b to the bottom, those are the parameters, and immediately calls normalize to reduce it and turn it into, let's say in case of 8 divided by negative 12 to negative 2 over 3. Other constructors, if you have a constructor with no parameter, default value for top will be 0, default value for bottom will be 1. And if you have a fraction constructor that only receives one parameter, that t is assigned to top and the bottom is equal to 1. Right? So if you want to, so a fraction such as 8, if you create such a fraction, really that is going to give you 8 over 1. Right? There is the numerator function that returns the top. There's a denominator function that returns the bottom. Normalize, we discussed the code. Go over the code. You got to grab again a pen and a paper and just go through it and see how it works. And then you have the operator plus. This is a non-member function. Right? This is a non-member function. What do I mean a non-member function? Let me go back to the fraction definition. If I go in there, that's the header file. If you notice, you have operators that are defined inside the class. Those are defined as member function. And then you have operators that are defined outside the class. These are non-member functions, right? So they are basically defined outside the class. Right now, I believe we are implementing the plus operator that receives left and right. Right. So going back to the fraction, overloading of the operator plus, it returns another fraction, receives two fraction, the left fraction and the right fraction. Here's an example. Let's say this is the left fraction and there's the right fraction. We are adding them. And how do you add fractions? Well, you find a common denominator. In this case, you multiply 3 and 5 will give you 15. That's the bottom, right? And if you look at the code, we are creating a fraction called result, right? And in that fraction, here is the top. The top goes all the way. This expression creates the top, and then after the comma, this expression creates the bottom. What should be the bottom or denominator of the resulting fraction? As I said, you multiply 3 and 5. If you look at this, you have left dot denominator, that's left, denominator is 3, times right dot denominator. So you multiply it by, there is right dot denominator 5. So that creates the fraction. That creates the bottom of the fraction, which will be 15. Now, what about the numerator, the top of the fraction? Here is the top of the fraction. To create the top of the fraction, what you do, you multiply 2 right here, numerator of the left, and you multiply it by denominator of the right denominator. You multiply those two, and then add to it the basically the numerator of the right. There is the numerator of the right. It is right here. There's the numerator of the right, and then also multiply it by denominator of the left. There is denominator of the left. You add those two and you continue. That's how you add fractions from basic mathematics. Once you create this fraction with the certain top and bottom, you return the result. And that fraction will be the result. Same with subtraction. So you're overloading the subtraction operator. You have the left fraction, you have right fraction, pretty much go through the same computation, except that you're subtracting rather than adding. Multiplying two fractions. How do you multiply the fractions? Well, you multiply the numerators and you multiply denominators separately. So here it is. Create a fraction result. What would be in the top? Left numerator times right numerator. That's the top. Multiplying the numerators. And then what would be in the bottom? Well, left denominator times the right denominator. Fraction is created and it is returned. Keep in mind, creation of the fraction, this is a constructor. So the constructor of the fraction is called. And keep in mind, in the constructor of the fraction, normalize is automatically called. There is a fraction. Let me just show you the code if I can find it here. Constructor of the fraction. There it is. That's the constructor of the fraction. As soon as you make it, you call up normalize. So the results that we are creating here, these results, are automatically normalized, reduced, right? So the other operation, I have the division here, and this is unary operation. Unary operation basically changes the sign of the fraction. So if it is, for example, you have a fraction as a parameter, this is a value, and you want to change the sign of it, all you need to do is to create a new fraction, change the sign of the numerator. Notice I throw in that negative in there. Change the sign of the numerator. Denominator will still be the same, value denominator. So you've created a new fraction and you're going to return it. Now compare. How is compare done here? Compare is a member function. It's defined inside the class. Basically, when you call the compare, and an object will call compare function, and that object is a fraction. We'll call compare function and compares itself with this other fraction, right, which is passed as a parameter. So here, the left that you see here in comments that I have here, this left refers to the implicit object or the implicit fraction. In other words, the fraction that's making the call. That's the left operand here. If left is less than right, then you will return a negative number. Notice that return type is an integer. You will return a negative number. If left is equal to right, the fraction that's making the call is equal to the fraction that's passed as a parameter, then return 0. Else, if the left fraction is larger than the right fraction, return positive. Right? Now, how do you here is basically the operation that's being done in compare function. How do you compare two fractions? For example, between these two fractions, which one is the larger of the two, 2/3 or 3/5? One way to figure this out is to do the cross multiply. By that I mean multiply 2 by 5, the numerator of the left multiplied by the denominator of the right, and multiply 3 by 3, denominator of the left times numerator of the right. And then check which one is greater. So in this case, 2 times 5 is greater than, which is 10, greater than 3 times 3, which is 9. Therefore, the left fraction is larger. 2/3 will be larger. So that is basically, that's what's being done here. So you are going to grab the numerator here, which is the numerator of the implicit object, the object that's making the call, multiplied by denominator of the right fraction, and then subtract. In this comparison, instead of really comparing it visually, what you do then, you're doing a subtraction in the operation that you see here. Then subtract denominator of the implicit fraction times right numerator. Now with that subtraction, either the result is positive, negative, or 0. And that positive, negative, or 0 will tell you whether which one is larger, right? So this is compare. Now, once you define compare, then overloading the operator less than, here is the operator less than that you want to implement basically. All you need to do, by the way, this operator less than is a non-member function. Receives two fraction parameters, left and right, and returns a Boolean. So all you need to do is to return left and let the left object make a call to compare and receive right fraction as a parameter. Left dot compare right. If the result, which is based on this computation, is negative, you return basically a true here, right? That would be true. Otherwise, a false will be returned basically. Same thing for the other operations. Basically, left makes a call to compare, right? So it's a simple, nice implementation of all the operators, all the comparison or relational operator, by making a call to compare. We'll handle it basically. All right. So I'll let you look at that, and then you have the output stream. That's the output operator basically that we are overloading for fraction. The output stream returns a O stream reference. The name of the operator is right there, then less than, less than. The parameters are always the same as you see here. OStream reference out, constant fraction reference, and the name of the parameter is value. So how do you print a fraction? Well, use the OStream out. You want to display the numerator, value.numerator, divided by value.denominator, and return out. And that will print it basically for you. Right? And then the input operator, you can look at it, not as important. I mainly want you to look at the output operator. Let's go to main. Here is the main fraction, main function that tests the fraction. So we are creating a fraction a. The default constructor is kicked in, so it will be 0 over 1. That's the fraction that's going to be created. So that's a. A is equal to that 0 over 1. The fraction with one parameter, this is 4 is passed, so that will create 4 over 1. So b here is equal to 4 over 1. And then the fraction c that receives 2 parameter, what happens here, the normalize is called, the fraction is reduced, and negative is passed to the numerator. So really this c is equal to negative 3/4. Right? And notice we have overloaded the operator out, the output operator for fractions. So I can actually say C out A, so the fraction is printed. Same with B and same with C. So if I run this, just let's look at the beginning of it. Let's run this, and you will notice. Okay, let me just see. Build, yes, build it. Did I change something? So here it is. The constructed values are 0 over 1, 4 over 1, and negative 3 over 4, which is good. So I'm going to leave this here on the screen. C out, value of C is the numerator divided by denominator. The value of C is negative 3/4. That's correct. So individually, rather than using the overloaded operator, output operator, we are actually constructing the output, basically explicitly looking at the numerator and denominator and looking at value of C here. We are adding 2 fractions, B plus C. The addition of B plus C, and here it is. 4, that was B, plus C, which is equal to negative 3/4, is equal to D. And in here, output is 4 plus negative 3/4 is equal to 13 over 4. That's the result that you're going to see. We have then D is equal to B minus C. We do the subtraction here. You see that there's a subtraction, and we do right here, for example, that's the unary operation. We are changing the value of C to negative, and we are looking at the output, right? So all the operations are tested here. So let's go further down, checking to see whether 2 fractions are equal, right? Because we have overloaded the equal for fractions, right? Where was this? This is the operator equal. We have overloaded that operator for fractions, so we know when 2 fractions are 0. When you compare it, the result of compare is 0. And also, at last, we have these 2 other fractions, right? We create a fraction A, which is equal to 6 over 8. After normalization, then this is 3/4. Then another fraction, 7/8. So this is B is equal to 7 over 8, right? And then we do the comparison. We have again overloaded the comparison function. So if A is less than B, is it true that A is less than B? This is B, 7, 8. If I do the comparison, this is B, by the way, right? If I do the comparison, 3 times 8 is equal to 24. Right? I multiplied 3 times 8, 24, and then we have 4 times 7, that's 28. Well, B is larger. So A is less than B, compare is successful. Let's see what we have. That is true. That is true. Compare is successful. So hopefully this has been useful. Please look at the fraction, study the fraction. Once again, operator overloading is important. Every time you define your own classes, such as fraction, you want to overload the operators, especially the arithmetic operators if needed, for those classes so that you can apply those operators to the fractions. In here, C++ doesn't have fraction data type. We defined a fraction data type as a class and overloaded the operation addition, subtraction, multiplication for it so that we can apply to it.